Hi guys, this is Miss Rich coming to you for home. I had some requests about going over graphing linear equations to help you, and so I'm going to make two videos. This first one is actually graphing, putting the equations onto the graph, and the second one will be finding the equations when you're given information or given the graph. So here I have my first group of graphs that I want to put on a coordinate plane, which are in the form y equals mx plus b, slope-intercept form. And when you have y equals mx plus b, remember the number in front of x is your slope, the number that's added or subtracted is your y-intercept. So in this equation, my slope, which we call m, is 2/3. So we're going to rise 2 and run 3. And our y-intercept is -5, and that's 0, -5 is the coordinate. So we always start with the y-intercept, plot that on our coordinate plane. -5, 1, 2, 3, 4, 5, right here. And then from there we rise 2, 1, 2, run 3, 1, 2, 3. And I should use a ruler, and there is my line, and clearly show those 2 points that you crossed. So I always start with the y-intercept and then rise and run from there. So this next one, every now and then you'll run across one. This is still in y equals mx plus b form, but we have no number added here. So my y-intercept must be 0. So we're going to start with our y-intercept, which must be at 0, 0, the origin. Our slope is -6/7. So we're going to rise -6 from the y-intercept, which would actually mean to fall 6. 1, 2, 3, 4, 5, 6. And then I'm going to run from there 7. 1, 2, 3, 4, 5, 6, 7. Now if your slope is taking your point off the graph, you can always put the negative. This is the same thing as 6/-7. Put the negative in the denominator, and you can actually rise 6. 1, 2, 3, 4, 5, 6. Instead of running to the right, you'll go back 7. 1, 2, 3, 4, 5, 6, 7. So there is my line. Again, I should use a ruler. With a slope of -6/7 and a y-intercept going through 0. Our next one, y-intercept is 12. Always start with the y-intercept, which would be up here at 12. Our slope, m, is 5, which we always want to write slope as a fraction, so that's 5/1. So we can see if we rise 5 and run 1, we'll actually shoot right off this graph. So we can go down. This is the same thing as -5/-1, so I can go down 5 and back 1. And there's my line. And I can keep going down and doing that. Down 5, back 1, down 5, back 1 to get a good looking line. Alright, moving on. Standard form. If you have a line in standard form, remember standard form is ax plus by equals c, where a, b, and c are going to be integers, so your x and y are on the one side of the equation together. And when you have it written that way, your slope is always going to be the opposite of a over b. So in my problem here, I have the opposite of 2, -2, over b, and b is -5. -2/5 is also 2/5. So I'm going to rise and run 2 and run 5. Now, before I can use the slope, I always need a point. Well, remember, I could find the y-intercept by plugging in 0 for x. If I plug in 0 for x, I can actually cover up this whole value, because if I plug in 0 for x, this is all gone. And I can look, if I divide by 5, my y-intercept is -12/5. Yuck, don't want to use that. So let's look at our x-intercept. Our x-intercept is always where y is 0. If I divide by 2, my x-intercept is 6. a much nicer point. So I'm going to begin with my x-intercept this time, 6, 0. So start with that, 1, 2, 3, 4, 5, 6. From that, use the slope, rise 2, run 1, 2, 3, 4, 5. Get 2 points. Remember, 2 points determine the line, so as soon as I have 2 points, I have my line. Now, don't forget Vux and Hoy. Vux means vertical line, undefined slope, would have the equation x equals a number. Horizontal line has 0 slope. The equation would be y equals a number. If you can remember that, then you can solve these vertical and horizontal lines and graph them very, very quickly. So I see here y equals a number. I should immediately think Hoy, horizontal line, y equals a number. So I go to that y equals -7 on the y-intercept. 1, 2, 3, 4, 6, 7. And it is a horizontal line where y is always -7. And that should make sense because every point on this line, y is always -7 regardless of what x is. So here we have a vertical line with an undefined slope, also known as no slope. And our equation is x equals a number. So it's going to be a vertical line. I go where x is 2, 1, 2. And I make sure it's a vertical line. Its x-intercept, notice, is at 2. It has no y-intercept because it's never going to cross the y-axis. Okay, last two. If you're given some facts about parallel and perpendicular, here it says I want to graph a line that's parallel to y equals -2x plus 5 and passes through this point 1, -3. So I'm going to always start with the point I know, 1, -3. Plot that point. When I give you this parallel or perpendicular, all you're going to do is just steal this slope. So if the slope of this line that I was given, since this is in y equals mx plus b, the slope is -2. The slope of the parallel line, slope of parallel is what this means, is also going to be -2 because slopes of parallel lines are equal. So I need to use the slope of -2 over 1. So from the point I was given, I'm going to rise -2. So go down 2, run 1. I can do it again, down 2, run 1, down 2, run 1, as many times as I want to. And there's my line. I actually missed a point a little bit there, but should be using a ruler. But anyway, so don't worry about graphing this line. Just steal the slope from it and use it to find the slope of the parallel line. So this next one, same idea. We want to first plot our point, 1, 1, 1, 1. There it is. And all we're doing is stealing the slope. Don't bother graphing this line. The slope of this line is opposite a over b because it's the standard form, which would be -3 over -6, which is of course 1/2. Always simplify your slope as much as possible. But it says perpendicular. A slope of a perpendicular means you need to reciprocate it, flip it, and change the sign. It's now negative, it was positive. So if we use the slope, we're going to rise -2, so we'll go down 2, run 1, down 2, run 1 again. And there's that line. I hope this helped. Your next video will be on putting lines in equations.